Welcome back, guys, to Remote Explorations. As discussed in my last class, I will be starting with sequence and series, that is AP, GP, and HP today. We have already covered up most parts of the number theory, and since I have told you this has been a crash course, so I'm doing things not in much detail, but with great precision. So the exams are knocking at your doors. So on 11th May is ISI's entrance examination, and on 24th May is CMI's entrance examination. So you need to buck up, guys. So today I have some topics left from number theory, two to three small theorems. We'll just be doing that and moving on to APGP and HP. So without any further delay, let's start this. And don't forget to like, share, and subscribe the video. And do refer it to your friends and juniors who are preparing for these test examinations and aiming to have a mathematical journey. So our first topic, still in last class, would be my Fermat's theorem. There are some leftovers of number theory. What does my Fermat's theorem say? My Fermat's theorem says that if my p is a prime and a is any integer, then my a to the power p is congruent to a mod p. Now, as I have already told you the concept of congruence, that I am just revising it once more. A congruent to B mod n. This basically means n divides A minus B. So this is the result. A to the power P is congruent to A mod P, that is P divides A to the power P minus A, conditioned that my P is a prime. Now one more corollary or the special case. If my GCD, that is my HCF of A comma P is 1, that is my A comma P are co-primes. This basically suggests that my A to the power P minus 1, my P is already a prime and my A and P both are co-primes, is congruent to 1 mod P. So now this is a special case. My A to the power P minus 1 is congruent to 1 mod P if A and P are prime to each other, that is their co-primes. This is what my Fermat's theorem is all about. Okay. Next comes is my Euler's theorem. The repercussions of your quotient function and my congruences, that is residual functions. So this says that I have my two numbers n and a, and if my GCD of n and a is 1, that is my n and a are co-primes, then my e to the power phi n is congruent to 1 mod n. So now many of you would be confused, like what is my phi n? So phi n is basically your Euler's quotient function. As I had discussed in my last class, I will be just showing it to you once. This basically denotes the number of integers which are less than or equal to n and prime to n. Write it, but I will also be showing you the notes. Total number of integers less than or equal to n and co-prime with n. This is my Euler social function. Number of positive integers less than and or equal to n relatively prime to n, that is co-prime to n. This is what these were some properties, that is phi of mn is basically your phi of m into phi of n. So now my phi of p is equals to p minus 1 if my p is a prime. My phi of 1 has to be 1 since we do not have any positive integer less than 1. So and my phi of k, if my k can be expressed in the form of p1 to the power alpha 1 into p to the power alpha 2 into the pn to the power alpha n, where my p1, p2 and p dot up till all the way till pn are distinct primes and my alpha 1 and alpha 2 are distinct integers. Remind from being distinct, they are normal integers. Then my phi of k is basically your 1 minus 1 by p1 into 1 minus 1 by p2 dot up till 1 minus 1 by pn. So this was it. This is my Euler's function. Now, Carmichael's theorem is not that important. Next, we move on to Wilson's theorem. These applications, you need to have it covered up from somewhere. Since it's only a crash course, and I'm just going to show you the formula with much precision and approximation. Next comes up here Wilson's theorem. What does the Wilson's theorem say? We have a natural number n belonging to naturals greater than equal to 2 is prime if and only if my n minus 1 factorial is congruent to minus 1 mod n. Or in simpler terms, my n minus 1 factorial mine plus 1 is basically divisible by n. Divisible by n, or if I want to write it in the form of division notation, then n minus 1 factorial plus 1 is divisible by n. So this is what my Wilson's theorem is all about. So binomial, I will be doing it at my end of P permutation combination, which would be the next chapter after I am done with AP, GP and HP. Scales of notation, I'm not going to go. Anything more you guys want to have covered, I will just be checking it once. Arithmetic equations, not that much needed. That's it. So that's all for number theory, guys. Nothing more to say for number theory. I have done all the important things. Now we start up with your AP, GP and HP. That is my progressions. First, we'll be starting with the easiest one, which is my arithmetic progression, where my numbers are in the form of sum or differences. So now let me just basically tell you what is a progression. A progression is basically a series, normal series where the next number can be related in some way or the other with its previous number and with its upcoming number. That is what basically my progression is. So we have basically three types of progression: arithmetic progression, geometric progression, and harmonic progression. So I'll be starting with my arithmetic progression. Here, my consecutive terms are basically differences, are basically or probably my consecutive term can be got by adding some fixed number or subtracting some fixed number from the previous term. And the same happens for upcoming term. That is, here one normal notation is my A will be always denoting my first term, N will be denoting my number of terms of the series. This is basically I'm going to talk about a series whose terms are, for example, A1, A2, A3, all the way till AN. And my D would be the common difference. That is my second term minus first term. So common difference. Second term minus first term. This is basically what would be defining our arithmetic progression. So my ultimately my series can be written as an AP is always in the form of like this. So I have my first term, then comes up my second term, then comes my third term, then comes up my fourth term, all the way till my last term. Now, a very easy derivation of the formula to calculate out the nth term. If my first term is A, my second term is A plus D, my third term is A plus 2D, my fourth term is A plus 3D. Basically, I can write my first term as A plus 0D. So for 1, I am writing A plus 0D. For 2, I am writing A plus D. For 3, I am writing A plus 2D. For 4, I am writing A plus 3D. Basically, this gives us a pattern which says that for n I'll be writing n minus 1d. So a plus n minus 1 into d. This is what is the general term or my Tn of AP. Good. Now comes up my second term. I mean my second most important thing. This is my Tn. Now comes up my Sn. That is summation of nth series. So this derivation I'm giving you as a homework. I'm gonna write you the formula down and you are gonna prove it and just ping me in the comment box. And I will be doing it in my next class also. So my Sn is basically n by 2, where n denotes the number of terms in the series, into 2a plus n minus 1 into d. Or this can also be written as n by 2 into a plus a plus n minus 1 into d. So now this is my Tn or probably or my last term. So this can be written as my n by 2 into a plus Tn, and Tn is my last term. So this can be written as n by 2 into a plus L, where my L denotes the last term. So ultimately we come up with two formulas. This is the basic formula which you are going to remember. Therefore, if you want to summarize, summarizing the two most important formulas, this is an easy chapter, relatively easier than permutation combination of the previous one. That is number theory or polynomials. It's a relatively easy chapter. You just need to use some conventions and just use your ideas in precise ways. So summarizing, what do I get my formula? My Tn is your a plus n minus 1 into d, and my Sn is n by 2 into 2a plus n minus 1 into d. So these two are my mother formulas for this chapter. From general information, how do you take terms? Taking terms. If we are going for three terms, three d a minus d. So if I'm gonna take my three terms which are in AP, you can very easily take it as a minus d, a plus d. Some bit of lagging, guys. A minus d, a plus d. Next comes if I'm gonna take my four terms in AP. So that is gonna be like a minus 3d, a minus d, a plus d, and a plus 3d. Next up is my five terms. This is again gonna be a minus 2d, a minus d, a, a plus d, and a plus 2d. Now, one common logic for taking terms like this is whenever we are given a question like this, we are obviously given that my sum of the terms of the series is basically we are given fixed information. And if I'm going to take out my sum for this, like a minus d, a plus d, I can see my d gets cancelled and we are left with only a single variable whose result, whose value would be very easy to calculate. Similarly goes for four terms. If I'm given the sum of four terms, and if I'm gonna add all these four terms, so ultimately we are left with 4a. For an example, 4a is equals to k, so my a is actually coming out to be k by 4, and my k is in maximum cases it's a constant term. So we obviously have a fixed value, and instead of two unknowns, we calculate the equation to a single unknown and find out the value of that unknown. Next, one very easy question. I'm gonna do it. My question is, the first term of a series, that is a equals 5, last term that is my tn is 45, and my sn is 400. We need to find n is how much and t is how much. Easy one, just take 2 minutes to think about it. Yes, you have thought. I'm now gonna solve it. So what am I given? My first term is 5, my nth term is 45, and my Sn is basically 400. So as I have said, my formula of Sn is n by 2 into 2a plus n minus 1 into d. This is what is my formula for summation of series. So now what I can do is my 400 is basically n by 2 into, I can again write this as your a plus l as it. Yeah, this I can already write is as I have derived it n by 2 into a plus l. So this can be written as your 400 is equals to n by 2 into a plus tn. This is your 400 is equals to n by 2, and I know my values of a plus tn, so that is my 50. So 50 gives you my 8, and my n comes out to be a 16. So my number of terms I've already got is 16. See, this is very formula based. My n is equals to 16. Now we need to find out my d. Okay. So what do I have here? I will be using my tn to find out my d. I'm gonna do it on my side only. So my tn is given out to be 45, and my tn is basically a plus n minus 1 into d. So that is my 45. So my 5 plus, I know my n, which is your 16 minus 1, that is your 15 into d, is basically 45. So ultimately, my 15d comes out to be 40. I'm going to cut it with 5, so 8 by 3. So my d comes out to be 8 by 3, which is equals to 2 by 3. So this is what it is. So I hope we are clear with it. So we all know what is an arithmetic mean, or probably my average. Arithmetic mean of A and B is basically the average, which is your A plus B by 2. This is my arithmetic mean. Good. Yeah. So my next question is a very repeated question. It has been repeated in various examinations. Probably, if you would have been in FITZY or some coaching institute, it would also have been repeated in the booklet of the arithmetic progression also. I'm going to give you that question, an easy one, but a little bit of tricky, probably. Might not be for you. It was for me in my first time. So my question is my sum of n-th terms. Sum of n terms of two arithmetic series are in the ratio of 7n plus 1 is 2. 4n plus 27. What do we need? We need the ratio of the 11th terms. Find the ratio of the 11th terms. Give an attempt to this one. It's a nice one. Take 2 minutes and just try to solve it. Yes, you have just seen it. I'll give it a solve. So what do we know? My sum of two series. So for first series, let my A1 be the first term and my D1 be the common difference. For second series, let my first term be A2 and my common difference be D2. So my number sum we both have in my like in both cases we need my sum of n terms, so my n remains constant. So for first series my sum of n terms would be n by 2 into 2a1 plus n minus 1 into d1, and for my second series my sum of n terms would be n by 2 into 2a2 plus n minus 1 into d2. This is my summation. So we are given these two are in the ratio 7 plus 1 is to 4n plus 27. So basically, according to the question, it would be n by 2 into 2a1 plus n minus 1 into d1 by n by 2 into 2a2 plus n minus 1 into d2. This would be your 7n plus 1 by 4n plus 27. So I can very easily cut these two. What do we need? We basically need the ratio of the 11th term. Needed is basically the ratio of 11th terms. So in my first series, what will be my 11th term? It would be your A1 plus n minus 1 into D. So basically T11 would be A1 plus 10 D1, and here also my T11 would be A2 plus 10 D2. So if in my LHS I put, what do I need here? I need this to be 10. Okay. And I also need this 2 to be cancelled out so that I can directly get my value from here. What do we do? A very simple trick. We know n minus 1. If my n is even, or probably my n is odd, then n minus 1 would be even and it will be divisible by 2. So what do I do here? I just put my n equals 21. Since if my 21 minus 1 comes out to be 20 and if I divide it by 2, it simply becomes 10d1, which is ultimately what we need. So if I put my n as 21, what am I left with here? I'm left with 2a1 plus 20d1 by 2a2 plus 20d2. Now this is, since we are putting it in my LHS to keep the value unchanged, we also need to implement it in my RHS. So in my RHS is basically your 7 into 21 plus 1 by 4 into 21 plus 27. So what I'm going to do, this side I can divide it by 2 very easily. So I am getting my ratio of my 11th terms a1 plus 10d1 by a2 plus 10d2. So ultimately what we are left with here, this side it would be your 148 and this side would be 21 for the 84 plus 27, which is 111. So I can reduce it with 3. So 309 to 137. With the 12. Probably no, it won't be going with 3. Sorry for this. It will probably be going with 37. So if I go with the 3 and this comes out to be 4. So ultimately my ratio of the 11th term of both the series is 4 by 3. One more question, an interesting one again. And this is gonna be in homework for you guys. Just solve it and ping me in my comment box. I'm ready to give you the answer. What is my question? This is my homework, by the way. The question is, if S1, S2, S3, all the way till Sn are the sum of n terms, are sum of n terms of the series whose first terms are, I won't be even, the language is a bit complicated. It might seem a bit complicated, but to figure out on your own, I'm not going to decode you the language since everything lies in the language. So what the sum of n terms of series whose first terms are 1, 2, 3, 4, dot dot dot, and whose common differences are 1, 3, 5, 7, dot dot dot. Therefore, we need to find the value of S1 plus S2 plus S3 plus all the way till SP, where that is my pth term. School question. Do give it a try. Nice one. I don't think, just a second. I have to minimize something. So I guess that's it for today. Nothing much. Easy topic AP. In my next class, I will be trying to do my GP. Yeah, I don't think anything else is left. I'll be just seeing if I get some questions. I have probably one more question I can do within my time, and if not, I will be leaving it in my middle and just giving you it to be a homework again. Is this one question? What is it? In an AP. Nice question. It has already come in ISI's MCQ question once or twice probably. It's a repeated question. An AP summation of P terms is equal to summation of Q terms. Show that summation of P plus Q terms is 0. This is what you need to show. I'm not going to give you much time for this. Probably it'll probably take 1 or 2 minutes. So what would be my SP? I am generalizing it. That is, I am taking my first term to be A. Let first term equals to A. Common difference is equals to D. What will be my summation of P terms? So it would be basically your P by 2 into 2A plus P minus 1 into D. Similarly, what would be summation of Q terms? It would be your Q by 2 into 2A plus Q minus 1 into D. So I am given, since SP is equals to SQ, then my P by 2 into 2A plus P minus 1 into D would be basically equal to Q by 2 into 2A plus Q minus 1 into D. So I'm going to cut my 2 and 2. So I'll be simplifying the terms. Okay. So if I'm going to multiply this here, it will be my 2AP plus P into P minus 1 into D. And similarly, here it will be your 2AQ plus Q into Q minus 1 into D. Okay. I'm gonna simplify it somehow. Again, 2AP plus P squared D minus PD is equals to 2AQ plus Q square, sorry, 2AQ plus Q squared D minus QD. So if I'm going to take all the terms to my LHS, what am I left with? I'm going to take my 2A common, so I'm left with my P minus Q. Again, my D common, so I'm left with P square minus Q square. Again, I'm going to take my D common to Q minus P equals 0. So, and from here, it is a homework for you. Just complete it. It will be the same process. Yeah, so that's it for today, guys. Short one. I have got some work in my college too. Do like, share, and subscribe the video. That's it for today. Goodbye. See you soon. That is most probably day after tomorrow or the day after that for the lecture 2, where I will be starting, where I will be solving the HW questions, probably one and two more questions about arithmetic progression, and we'll be going on to geometric progression. So yeah, that's it for today, guys. Bye.